Hi and welcome to today's class. It is the 22nd of May and this is class number 62. So today we're going to focus on triangles and the majority of this is probably revision from primary school. So there are four types of triangles that we're going to focus on today. They are equilateral, right angled, scalene and isosceles. So the first type of triangle we have is an equilateral. So think of that start, equi means equal. Lateral comes from the Latin for sides, so they are equal sides. All sides have the same length, but also all angles are the same size, and all angles are 60 degrees. The second type we have is an isosceles triangle. Two sides are equal in length, and the angles opposite the equal sides are also equal. So isosceles actually comes Greek, and it's isos means equal and skelos means leg. So this actually means equal legs, isosceles. Okay, so this is coming from the idea of having these two legs, these two sides that are of equal length, and then at the bottom having these equal angles. So just to be aware that the symbols on the line show that sides are equal in length. So you can do two dashes. For an equilateral, we usually only have one dash, and the matching number of dashes say that that's the equal side, because you might have, say for example, a rectangle, opposite sides are equal, so you have two pairs that are equal. We can use two dashes, one dash, three dashes if we want. Usually for angles, something like these two blue angles being the same, so the same kind of symbol or the same coloring might indicate to us that they are the same size. Third type of triangle is called a right-angled triangle. It is a triangle that has a right angle. Now you might have a right angle triangle that is also isosceles. That is possible. So it's not that it can't be something else with the right angle triangle, but this here has a long side that is opposite the right angle. That's called the hypotenuse, and we see a lot more about that next year. The fourth type is a scalene triangle. So again, right angle triangles could be scalene, but scalene have three unequal sides and three unequal angles. It's also good to note that we have what's called an acute triangle. So an acute triangle is a triangle where all angles are acute, and an obtuse triangle where one of the angles is obtuse. So here we have a triangle, and it has three sides, three angles. So it has three sides and three angles. So each corner of the triangle is called a vertex. Plural for vertex is vertices. So it comes like our index and indices, which is another fancy name for power. So think of your BIMDAS, the I stands for indices. So an index is a power, it's singular. So vertex, vertices. The triangle above is called triangle ABC, or if you're super lazy like me, you'll use this symbol. Symbol for triangle, super simple, it's a triangle. So that means triangle ABC. So you could call it ABC or BAC or CBA. Order is not important here. It's not like naming an angle, as long as all three vertices are included. The angle of the vertex can be written as angle B or angle ABC. So that goes back to our naming of angles. The size or measure of ABC, of angle ABC, is written with these straight lines. So that's a refresher of some things we've learned over the past few weeks. Triangle is enclosed by three line segments. Line segment is a piece of a line. Remember, the line goes on forever. So line segment, piece of a line. Now I have a little bit of an investigation for you to do instead of homework. I want you to go and find some kind of piece of paper, please. I would like you to draw a triangle, any triangle. And what I would like you to do is to cut out that triangle. When you've cut out that triangle, I want you to mark in the triangle angles, so angle A, angle B, angle C, like they've done here. And then I want you to tear off the three angles and place them together. So it's giving you a pretty good go here, what I need you to do. I want you to put those three pieces together with the vertices touching, so the points of those triangles touching. I want you to see what you discover. So pause the video now and you can go give that a go. Okay, so obviously you won't be able to compare the results with other students, but if you've done it, you will notice that it will have made a straight line. And that is not coincidence. And you can go draw a completely different triangle and try it. Try catch it out. Try do mad triangles and catch this out. But what you'll discover is all triangles, no matter how you draw them, the angles will add up to 180 degrees. So here's what we have. In any triangle, the angles add up to 180 degrees. So let's look at a quick example. Let's see how we could use the idea that they add up to 180 degrees to work out some missing angles. So first one I'm going to do here, I have a 90-degree angle here and a 42-degree angle. So what I'm going to do is I'm going to add 90 degrees plus 42 degrees, and that's 132 degrees. I know it should all add to 180, so I'm going to do 180, take away 132 degrees, and that gives me 48 degrees for A. So question 2, we have, do you notice all three sides are the same, so they're equilateral. So I know that all angles in an equilateral are the same, so all angles have to add to 60 degrees. And the reason is, if the three angles are the same and they all add to 180, 180 divided by 3 will give me 60 degrees. 3 here, question 3, C and D, because I have an isosceles triangle, they will be equal. So what I'm going to do is I'm going to have 180 degrees, take away that 20 degrees, so that's 160 degrees, and that's going to be split evenly between C and D, so that's 80 degrees, so C is equal to D is equal to 80 degrees. And question 4 here is a scalene triangle, so I'm going to add 72 degrees plus 68 degrees, which gives me 140 degrees. They should all add to 180, so E is going to be 180 minus 140, which is 40 degrees, so E is equal to 40 degrees.